Alright, so picking up where we left off. So we have our computed leads, and then we have we call 1, 2, and 3 our limb leads. And that's because these are actually going to be skin electrodes stuck on the limbs, okay? So to get these leads, we're going to make a triangle, and I'll show you how they look at the heart. So we put this triangle, and when I draw this triangle, you need to imagine it like it's laying over somebody's thorax. I'm a terrible drawer, so I drew a stick person. So it's laying over somebody's chest. The base of the triangle, which is up on the top, is laying across my chest. And if you think about like guys are supposed to have narrower hips, right, than they are their shoulders, it makes sense if you think about it that way. Or if you go to the back, you can see the V on some guys who are ripped, more ripped than I. So yeah, the way we think about that is that way. Now we're going to stick specific electrodes on the skin so that we can be able to tell where the specific lead is. So our first lead is lead 1. So our first lead relies on a skin electrode that is stuck on our right arm and a skin electrode that is stuck on our left arm, normally near the wrist. All right? They're going to stick them on here, and then we're going to be able to listen to the electricity move between those two points, right? And when it moves towards a positive side, we're going to get a positive deflection on the graph. So like this, a positive deflection, right? And when it moves away from a positive lead, we're going to get a negative deflection on the graph. So like right here. That's it moving away from the positive end of the lead. So our positive end of the lead on lead 1 is right over here on our right arm. Our left arm, excuse me. Think about it that way, and backwards. And we're going to get a view of the heart and how electricity is moving at a 90-degree angle, or 180, excuse me, across our chest from that lead. Now our lead 2 is going to rely on this this right limb lead and a lead down here on one of our foot, like around the ankle they usually stick it. And when they stick that on there, we can measure the electricity from those 2 points again. We get a negative lead and a positive lead. And we're going to be able to listen in on electricity moving between those 2 points again. So again, if we're going this way, we're going to be getting a positive deflection. If we're going this way, we're going to be getting a negative deflection. All right? And then the same thing with lead 3 here. And it's going to be looking, so our lead 2 is looking from this way down to our foot. Our lead 3 is going to be looking from this delt down to our opposite foot, or same foot, whichever way you want to look at it. They put 2 different electrodes on there, so it doesn't really matter the way you want to look at it. Yeah, so if you wanted to think about that, it would look like this. Stick person again. So our lead 3 would be using this skin electrode stuck on this wrist, and we would have one down here on this leg. And you'd be measuring the electrical impulse and the way it's traveling in between those 2 points. All right? And that's why we don't have something like that looking there. Now we have our 3 computed leads. These are also looking straight at the heart. So when I'm saying the different views of the heart, if you look straight on at something, you're looking the way the electricity is moving this way or that way. In the frontal plane, right? Coronal plane. So we're going to have these 3 computed leads. So AVF is going to be computed from lead, the midpoint between lead 1 and the SA node in the heart. And then our AVR is going to be measured from the midpoint of line 3 or lead 3 to the SA node in the middle of the heart, which is right here. And then our AVL is going to be measured from the midpoint of lead 2 to the SA node of the heart. So what does that get us? So if you laid that thing on my chest, laid the drawing on my chest, you'd get different views of the way the electricity is moving. And if we get any disruptions in that pattern, which is a specific pattern it follows, and that's why we kind of went over axis deviations, if we get any deviation in that specific pattern, it can tell us if something's wrong and what part of the heart is responsible for that thing being wrong, right? Because if we put our heart in the middle of this triangle, like right there, which the SA node is the middle of this triangle, we're going to be able to see, look, if we follow AVL, we can see a lot of the right side of the heart, especially the right atrium. If we look at the lead 1, we can get a lot of the top or the posterior aspect of the heart. And we can also get our lead 3 can tell us what's happening on this side of the heart. So that's what we're talking, that was what she was talking about with views of the heart, was that, oops, I almost dropped that, was that each lead is going to be looking at a specific side of the heart and the way the electricity is moving across that side. And if we get a disruption in it, it'll tell us that there's an injury at that point, or an arrhythmia, which will manifest itself in different ways. All right, so those are the frontal leads. 1, 2, 3, AVF, AVR, and AVL. Now, what was she talking about with axis deviations? Axis deviations mean there's a specific way our conduction system works in our heart. And it's oriented, because of our anatomy, to conduct the signal from the SA node, the AV node, bundle of His, bundle branches, Purkinje fibers. And those are positioned in our heart, and they are positioned going this way, down to the left. She said that a million times, right? And since the electricity is moving that way, if it's not moving that way, we can tell from all these different leads in the 12 lead where it's moving. And if it's moving somewhere off, something is wrong, okay? So normally it's going to be moving down to the left from the SA node down through the bundle branches and all that. And you've got to sum up all the different leads and get vectors and add vectors together, blah, blah, blah. Physics, it's hard. So don't do that. Do what she said, which is pay attention to 2 leads, lead 1 and lead AVF. So lead 1, I said its negative pole was on our right hand side, and our positive pole was on our left hand side. So what's it mean if we have a positive deflection in our QRS symbol on our lead 1? That means that the electricity is moving towards our left hand side, okay? Because it moves this way towards the positive pole. So if that's true, if we have a positive deflection in that, then we're going to go to our AVF. Now AVF runs, it's a view of the heart where it's going from the center of line 1 to the SA node. So it's basically straight up and down in the thorax. And if we look at straight up and down, we know which way the electricity is moving. If we're looking at 2 different places, and the place 1 is our SA node, and the other place is right here up on our, we'll say our sternal notch. Which way is it moving? Well, if it's moving up, it's going to be a negative deflection. If it's moving down, it's going to be a positive deflection, because our SA node is used as our positive lead in this case. So, and that's going to be the case for all these computed leads. The SA node is going to be the positive lead. So if we have a positive deflection in it, we're going to get